Okay, we're gonna start off with a quick review of our factoring. So on question number 1 here, we can see that we've got 4 terms, so that's going to be factoring by grouping. So I'm going to group the first 2 and the last 2 terms. The greatest common factor out of the first 2 terms is an x squared, so I'm going to factor out an x squared, and that's going to leave me with x subtract 3. Out of the second 2 terms, the greatest common factor is 16, but I'm going to use negative 16 because I want my leading term to be positive. So I'm going to factor out negative 16, and that's going to leave me with x subtract 3. Now I've got my binomial term, my parentheses are the same, so now I'm going to factor that out. So that's going to be x minus 3 times x squared minus 16x. X squared minus 16x is the difference of 2 squares, so that will continue to factor. So I'm going to factor that to an x plus 4 and an x minus 4. Okay, number 2. I'm looking at number 2, and I notice that there's a greatest common factor. They all have variables, so I know y to the third is the greatest common variable. Since y to the third is the end variable here, I know they all have a y to the third, and they both are divisible by 3. So I'm going to factor out 3y to the third. That's going to leave me with y squared subtract 25. So y squared subtract 25, that's going to factor. That's difference of squares, so it's going to go to y plus 5 and y subtract 5. Okay, question number 3. I've got 2 terms here, so it looks like to me, once again, I'm looking on the end, and I notice that they've all got x squared, so I know I'm going to have an x squared. I would check to see if 16 divides into 686. It doesn't. I think the only thing that divides into both of those is a 2. They're both even, so your GCF is going to be a 2x squared, and that's going to leave you with 8x to the third plus 343. Okay, this underneath in our parentheses is now going to be sum of cubes. 8x to the third plus 343. That's our sum of cubes pattern. So remember, in our sum of cubes pattern, we're going to have a smaller parenthesis and then a bigger parenthesis. In the smaller parenthesis, we can get those first 2 terms by taking the cubed root of 8, which is 2, cubed root of x to the third, which is x. Same sign, so it's a plus. And then the cubed root of 343 is 7. Okay, now to get the back end, just compare first term here. So 2x times what gives me 8x to the third? That would be 4x squared. And then compare the last 2. So 7 times what will give me my 343? That would be 49. Okay, in the sum of cubes pattern, if this sign right here is a plus, then this sign is opposite over here in the other parentheses, so this one's got to be a negative. It always ends in a positive, so you're just left with finding that middle term. And remember, we can find that middle term by multiplying the first and the last term together in the first parentheses. So 2x times 7 is 14x. And there it is, factored. Okay, number 4 looks like grouping again. So I'm going to group the first 2 and the last 2. So greatest common factor out of the first 2 is x squared. So that's going to leave me with x plus 7. And out of the last 2, it's a negative 9. So that's going to leave me with x plus 7 again. Now, x plus 7 is the common factor, so x plus 7 comes out, and that leaves me with x squared minus 9, which is difference of squares again, so we're going to keep factoring that one. That's going to go to x plus 3 and x minus 3. Okay, and our last one, number 5, looks like it's got a GCF, and it ends in x squared, so we know we're going to have to use x squared for our variable, and all 4 of those terms are divisible by 4, so 4x squared. That's going to leave me with x to the 4th minus 5x squared plus 6. Okay, so now when we factor this one, 2 parentheses, so x squared and x squared. Now, factor pairs of 6 are 1 and 6 and 2 and 3. You have to be careful with 6. 6 is tricky because I could get a 5 out of a 1 and a 6 and a 2 and a 3. So you have to make sure all of the signs match. So remember, this ends in a positive, so I know both of the signs in my parentheses below are going to be identical. And since I want a negative 5x squared, they're going to be a negative 2 and a negative 3, and our 4x squared out in front. Okay, x squared minus 2 is the difference of squares. 2 is not a perfect square number, but you can factor it if you use the square root. So x plus the square root of 2, x minus the square root of 2. X squared minus 3, that's x plus the square root of 3, and x minus the square root of 3. Okay, so both of those are difference of squares. You just have to factor them with a radical. And that's our review on factoring. Okay, now today's lesson is going to deal with systems. And there's lots of different ways to solve a system. And one of the ways is to solve it by graphing. So if you want to solve by graphing, you're just going to graph the two equations that are given, and then you're going to find out where they intersect. And then that's going to be your solution. And as we go through this unit, we'll use some other methods besides graphing, but today is all about graphing. So first equation given up here is a line. So if I'm going to graph that, I'm going to go down to -8 and put a point. And then the slope right here, here's my slope, is 2 over 7. So I'm going to go up 2 over 7. And now it'll be off my graph paper if I go up 2 over 7 again. So now I'm going to go in the reverse direction. I'm going to go down 2 and left 7. Okay. And then I'm going to just sketch that line in. Oops. I'll try it again, see if I can get all 3 points. Okay. So there's our line. And now we'll graph the other line. So you could graph this line right here in the format that's in using the x and the y intercept, or you could solve it for y and put it in y equals mx plus b, either one. I think I'll show you both. So if I'm going to do intercept, if I put a 0 in for x, I would put a 0 right here, then 2y equals 6, so y equals 3. So 0, 3 would be a point on my graph. Okay, if I do the other intercept, that means I would let y equal 0. So put a 0 right here, and 3x equals 6, so that means x equals 2. So then we would have another point right here at 2, 0. Okay, so that's doing the intercept method. Now, if you wanted to solve it for the letter y, you would say 2y equals a negative 3x plus 6, and then you would divide everything by 2. And you'd end up with y equals a negative 3 over 2 x plus 3. And notice if we come over here, it kind of lines up with the 2 points we already had. If I start here at 3 and I count down 3, 1, 2, 3, and then to the right 2, that puts me in those intercepts. I can keep doing that pattern. I want to see where it crosses the blue line, so we need to keep counting out our pattern. So down 3, 1, 2, 3, over 2. Down 3, over 2. Down 3, over 2. Okay, so here's this line right here. So our solution is right where these two intersect, right here, where these two intersect, right there. So that's not on a grid mark, so we're going to have to do our best guess and write what we think the solution is going to be. So we're going to count over 1, 2, 3, 4, 5, 6. I don't know. I'm going to say 6.4. I'm guessing. And I'm down 1, 2, 3, 4, 5. I'm going to say 6.3. Guessing. So that's an approximation. So that's one of the downfalls of graphing or solving a system by graphing is that, number one, if you don't graph accurately, it's hard to tell. And two, you may have to guess the solution instead of finding out what its exact value is algebraically. Okay, so here's another system. So this top equation up here is a circle. And the center of this circle is at 3, 0. And the radius is the square root of 13. All right, so 3, 0 puts me right here. Now, square root of 13, I know square root of 16 is 4, and square root of 9 is 3, so square root of 13 is in the middle somewhere. So it's somewhere between 3 and 4 if you don't have a calculator. So we'll just say about 3.5 to count it out. So 1, 2, 3 and a half, and a half, 1, 2, 3 and a half, 1, 2, 3 and a half. Okay, now if you wanted to get some exact points on that circle, so we kind of guessed those were guessing, but if you wanted to get some exact points, then you would want to do the Pythagorean theorem where it was a squared plus b squared equals c squared. And what you want to have happen is that a squared plus b squared is going to equal 13 because that's what the radius is 13. So can you think of numbers that you can put in there that would give you 13? Well, I could think of 4 plus 9. So that would mean A is 2 and B is 3. So 2 squared is 4, 3 squared is 9. Add that together, that would work for the Pythagorean theorem. So when you come over here to your circle, you can do a 2, 3 combination. So what I mean by that is start at the center, and I'll count right 2, 1, 2, and I'll count up 3, 1, 2, 3. That's a point on your circle. Now I'm going to count right 3, 1, 2, 3, up 2. That's a point on my circle. And I can do that combination all the way around. So I'm going to go left 3, up 2, left 2, up 3. You can see how this is giving me more points on my circle. Left 3, down 2, left 2, down 3, and then right 3, down 2, right 2, down 3. Those were all 2, 3 combinations. You can sketch your circle in. It kind of gives you more points on your circle too, so you can draw your circle in better shape. So there's our circle. Okay, and then we have, of course, this one right here is a line. So let's go graph that one. So we're down 2. So starting point's right here at -2, and then the slope is up 2 over 3. So up 2 over 3, up 2 over 3, up 2 over 3. Because I did those other points, I can actually tell that these 2 points right here, this one and this one, were on grid marks. Those were exact. So our solution on this one would be 0, -2, and 1, 2, 3, 4, 5, 6, 2. Those are our 2 intersection points. Okay, number 3. This one, top one is the absolute value. So that's our V shape. So the vertex of the absolute value is at -1, -2. So let's come over here at -1, -2, put our vertex. And then the slant of that V shape is going to be out in front here, the 1/2. So we're going to go up 1 to the right 2. So up 1 to the right 2, up 1 to the right 2, up 1 to the right 2, up 1 to the right 2. Now I'm going to go the other direction because I want it to be a V shape. Up 1, left 2, up 1, left 2, up 1, left 2, up 1, left 2. So there's our absolute value. Okay, now the bottom one is a parabola, and it's in standard form. So in order to find the vertex in standard form, you could complete the square, or we'll just do our normal axis of symmetry formula. So I'll start with x equals opposite of b over 2 times a. So opposite of b is 6 over 2 times 1, so that's 3. So that means your vertex is 3, comma, and now you have to put 3 back into the original equation. 3 squared minus 6 times 3 plus 9. So 9 minus 18 plus 9 is 0. So 3, 0 is our vertex. And A right here is 1. So that means my parabola is just going to follow the 1, 3, 5, 7 in the vertical direction. So up 1 over 1, up 3 over 1, and then up 5 over 1 if you keep going. So here's my parabola. So where did those two intersect at? Just right here at 3, 0. So your solution is 3, 0. Okay, number 4 is an absolute, nope, that's not absolute value. Number 4 is quadratic in vertex form. So this is, vertex is at 4, 3. So we'll come over here, 1, 2, 3, 4, 1, 2, 3, put our point. And I notice that A is -2. So that's going to take my 1, 3, 5, 7 pattern, and we're going to multiply that by -2 to see what we're going to graph. So we're going to start at our vertex. We're going to go down 2 over 1, down 6 over 1, and then down 10, we'd be off our graph paper. So there's our parabola facing down. Okay, and then this is our square root. So the starting point on the square root, so the start point is 5, -1. And remember, our shape looks like that, and it's a 1, 3, 5, 7 pattern going right to left, not up and down. So we'll start here at 5. 1, 2, 3, 4, 5. -1 puts me right here. And the other thing I notice is that I have a negative sign here. So instead of going up 1 over 1, up 1 over 3, I'm going to go down 1 over 1, down 1 over 3. So there's our square root function. And we've got to make a guess again because this is where they intersect, and that's not on a grid mark. So that's going to be at 1, 2, 3, 4, 5. I'm going to say 5.7, comma, -1.7. Just guessing. So somewhere around there. It's between 5 and 6 and between 1 and, or yeah, not quite 2, right? Between 1 and 2, -1 and -2 for the y value. Okay. So that's if you just have equations and you're just trying to figure out where the two intersect each other. You can do some of those on your calculator if you have a graphing calculator if you wanted to just to see. You would just use the intersect button to find out where that solution is. It's under your second calc equation menu where all of those functions are that we've kind of talked about in class. Okay, now this one's changing to inequalities. So the other ones had equal signs. These have inequality symbols. So just as a quick refresher, if your inequality symbol is underlined, that means it's equal to, and you would draw a solid line. So this one is underlined, so this would be a solid line. Okay, this one is not underlined. So when I go to graph it, it would be a dashed line. This is just less than, so this would be a dashed line. All right, so let's graph y is less than 3x minus 2. So I'm going to come down here to -2. I'm going to go up 3 over 1, up 3 over 1, up 3 over 1. I'm trying to get a good line here so that I can, this is supposed to be dashed, so we're going to dash that. Okay, so here we go. Now, it says y is less than 3x minus 2. So since it's less than, you have to decide, are you shading above or below the line? So it says y is less than, so on lines, a good trick is to go find out where your graph crosses the y-axis. So it crosses right here. So just start right there, put your pencil right there, and less than would be below. And now you can see you're shading all of this area over here. All of this would be the shaded area. So let me shade that. I'm going to do a highlighter pencil, and I'm going to shade this area here. So erase that. So it's going to be everything over here is getting shaded. Okay, so that's the first equation. So now the second equation is 2x minus 3y is greater than or equal to -9. I know I'm going to have to draw a solid line when I solve that. This time I will just, you could do this one in intercept form also if you want to, but 2 doesn't divide into 9 evenly, so that would be a half. So I think I'll just do it in y equals mx plus b form. So I'm going to subtract my 2x. And then I'm going to divide by a -3. So now the thing you have to remember is that when you're working with inequalities, if you divide or multiply by a negative number, you have to reverse your symbol. So now instead of a greater than or equal to, it's got to be a less than or equal to a positive 2/3 x plus 3. So we're going to go up here to 3, and then we're going to go up 2 over 3, up 2 over 3, up 2 over 3, and down to left 3, down to left 3. Okay, so this one gets to be a solid line. So here we go. Here's our solid line. And now I'm going to shade that. So let's get a different highlighter here. I think I'll go with blue. So once again, I'm going to go right here where my line crosses the y-axis and it says y is less than. So less than would be below. So that means I would be shading everything below. So you can see with my highlight colors that the solution set is where the two overlap, and that's where my highlighting color is turning green. So this area right here. So you can shade each one individually and then make the answer set darker, or you can just wait till you know where the answer set's going to be and then just shade that one. But somehow let me know what the final answer set is. So for this one, it would be the area that's green. Okay, next one. We've got an absolute value and a circle. So the absolute value vertex is 1, 3. So I'm going to come over here 1, up 3. And then my slant is out here in front, so it's a -1/4. So I'm going to go down 1, right 4, down 1, right 4. And I'm going to go the other direction to make it symmetric. Okay. And there we go. So this one is saying y is less than or equal to the absolute value. So this is going to shade below. If you're talking about less than the absolute value, we're going to be shading below. So it's going to be everything below. So all of this. Okay, almost there. And like I said, you could wait till the end and do the final answer at the end if you want. All right. So there we go. That kind of gives us a good idea of what's happening. Okay, so now we're going to graph our circle. So the center of our circle is 1, 1, and the radius is 5 because it's a square root of 25, so radius is 5. So 1, 1 is right here, and then a radius of 5, 1, 2, 3, 4, 5. Okay, and then sketch your circle in. Okay, so that's not a very good looking circle, sorry. Hopefully yours looks a little bit better than mine did. Now, this one says it's the circle is less than or equal to 25. So if it's the circle part that's less than or equal to the radius part, then that means you're going to shade inside the circle. So less than is going to shade inside. So if I shade inside my circle, then you can see the green part again is the final answer. Okay. All right, next one is an exponential. Y is less than or equal to 1/2 raised to the x power. So unfortunately, there really isn't a pattern for this one. So we're going to have to do this one with a table of values. So we're going to have to do some work to see what we're going to do. So if I pick x is 0, then that means I'm saying 1/2 raised to the 0 power. And 1/2 raised to 0 power is 1. So that would be my first point. Okay, now if I pick 1, then I'm saying it's 1/2 raised to the 1 power, which is a half. So over here at 1, I'm now at a half. And then if I pick 2, you're saying 1/2 raised to the 2nd power, which is 1/4. So what's going to happen on this right-hand side as I keep picking my x's, I'm going to get closer and closer and closer to the x-axis. It's going to become infinitely close, but it's not going to cross it. It's going to become infinitely close. Okay, let's see what happens on the other side then. If I pick -1, then I'm saying I'm doing 1/2 raised to the -1 power. Well, 1/2 raised to the -1 power would be 2. It's just the reciprocal of 1/2. So that would be 2. So at -1, I'll be here at 2. Okay, let's see what happens when we do -2. So -2, so I've got 1/2 raised to the -2 power. Well, if I do the reciprocal of that and then square it, that's going to give me 4. So I'm over here at 2, and I'll be up 1, 2, 3, 4. So now you can see that this shape is our exponential shape, and it's just going to keep increasing exponentially. All right, so the original equation said, and it's a solid line because it was y is less than or equal to. So less than or equal to our exponential is going to be everything on this side. So all of this less than everything. So this kind of shape in here, all of this is less than or equal to our exponential. All right, so now let's do the other one. The other one is a parabola, and that parabola is in intercept form. So that means we know where our two x-intercepts are. So we have one x-intercept at 2 and the other one at -4. So 2 is right here and -4, 1, 2, 3, 4, right here. So with that, I know my axis of symmetry is right in the middle at -1. So that means my vertex has to be -1, comma, something. Well, to figure out what it is, let's put it back in the equation. So it's going to be negative, and then -1 minus 2, and -1 plus 4. So that's going to turn out to be a -3 and a +3. So a negative times a negative is a positive, and 3 times 3 is 9. So we're at -1, 9 for our vertex. And then this is just following, it's facing down because of the negative sign, and it's just following the 1, 3, 5 pattern. So down 1 over 1, down 3 over 1, down 5 over 1, and then down 7 over 1. Okay, so here's our parabola. And this says y is less than. So less than our parabola is going to shade inside our parabola. So we're shading inside our parabola here. And then once again, the green part is the final answer. There we go. Okay. And last one. This time it has 3 pieces to keep track of. So y is greater than or equal to -1. That would be a horizontal line. And solid because it's greater than or equal to. So just to help me remember, greater than or equal to is going to shade up, right? So that piece is shading above. The next one is a vertical line of x greater than -2. Well, it's greater than, so that's going to be dotted, not solid. And guys, if you ever forget and you're like, oh man, I just drew that and it was solid and I was supposed to make it dashed, you could just write the word dashed out to the side, especially if you did it in pen and you're like, oh, I can't erase this. Now I don't know what to do. Just write the word dash, then I'll know that you knew that it wasn't supposed to be solid. You just forgot when you graphed it and you didn't want to erase it. Okay, so that one's dashed. And then the other one, and that one says y is greater than -2. So just to help me remember, that's going to be going this direction. We're heading this way. So right now, I'm going to go ahead and shade that. Right now, I only have this section that's overlapping. So this quarter over here. Okay, and now we'll do the slanted line. So 2y, I'm going to subtract my x plus 4. Divide by 2. So y is less than or equal to a -1/2 x plus 2. So I'm going to come up here to 2. And then I'm going to go down 1 to the right 2, down 1 to the right 2, up 1, left 2, up 1, left 2. Okay. And that's a solid line. And then less than or equal to would be shading below that. So if I'm shading below that line, then it's just this green piece right here, this triangle piece. That's our solution set. So make sure when you're doing inequalities that I can tell what the final shaded area is. What's your final solution set? Okay, that's graphing systems.